in this section are outliers. Now, a way of thinking of outliers, they're data that's really far away, sort of really spread out. They're far away from the vast majority of data. And they can occur for different reasons. It could be just when someone's taking down data, they made a mistake. It was a slip of the pen. Another thing that could be, if you think back to the pennies example, we had a situation where if the pennies were before 1983, they all tended to weigh a certain amount. And after 1983, they tended to weigh a different amount. And the reason that is the composition of the pennies changed. So let me take a look here real quick. If we look back at scatter plots here, it looks roughly like this. So this is the pennies and weights. And so let's say this is 1983, and this is a weight of 2.5 grams, and this is about 3.1 grams. So pennies that were before 1983, their scatter plot tended to cluster around here. So about 13.1 grams. And then pennies after 1983, they were clustering around 2.5 grams. So what an outlier could tell you, let's say we have our weights here, and they're all very close to 3.1. So let's say like 2.9 to 3.2. And it just so happens they were pennies from before 1983. But then one penny from 1995, one kind of far out here, it would be, say, 2.4 grams. So all the pennies here are about 2.9 to 3.2 grams, but then you get this one from, say, 1995 that's 2.4 grams. Well, is that going to be an outlier value? And the outlier could tell you that this population of pennies that are after 1983, there's something significant about them, and they have different composition. And unfortunately, when we did our study, we only ended up getting pennies before 1983. So the outlier, maybe it hints to another population. So it could be the slip of the pen, or it could be some other significant things. So we're very interested in outliers. Now, they can strongly affect the mean, and I'm going to abbreviate standard deviation as SD. So they can affect those. Now, what the text recommends is always identify outliers and consider their effect, or consider their influence. And again, some kind of analysis with these, like, could have this been a slip of the pen? Could there be another population here that we're just discovering? Who knows? So these can be important to talk about in your report. All right, so is there a way to determine an outlier? Is there some other way other than just saying that, well, it seems kind of far away from all the other data pieces? There is a guide. So if a value is an outlier that's too far above the mean. Or maybe not the mean, I don't want to say that. Let's say it's going to be for values that are greater than the third quartile, that's that 75th percentile, plus 1.5, and here's the IQR. Again, that's that use of quartiles that's going to be really helpful, well, other than the 5-number summary. So if you're the third quartile, whatever data value or value that was, and you add to that 1.5 times the IQR, your interquartile range, whatever data value is beyond this number, that's going to be considered, doesn't have to be, but we could consider that an outlier value, if that's the case. Also, if the value is less than the first quartile, or the 25th percentile, minus 1.5 times the IQR, then we consider that value to be so small that it's going to be considered an outlier. So let's take a look at our Verizon data. We'll apply this. So with the Verizon data, we found out that our first quartile was 7.9. And now we need the interquartile range. So to calculate that, we need the first and third quartiles. This one is 21.5. Now this one we calculated in one of the earlier videos. This one the text is just giving to us. So this one's a data value. Let's see, this one, is there 21.5 in our data? Let's take a look. There is a 21.5. All right. So again, with your L values, if your L value, when you calculate it, that's the location of your percentile. If it comes out to be a decimal, you just go up to the next whole number, and that is the whole number location for your percentile. And so the 25th percentile, whatever L value that was, at that L value was rounded up. We got 7.9. For the 75th percentile, we got an L value. And it looks like it was a decimal number. We rounded it up, and the data value at that location was 21.5. So let's get our IQR. Well, that's Q3 minus Q1, and that comes out to 13.6. So now what we want to compute are sort of the boundaries for our outliers. Now to do that, what we'll do is let's find the upper boundary. In other words, any data value beyond this boundary is going to be considered an outlier. So that boundary is Q3 plus 1.5 times the IQR. Now Q3 is 21.5. And then the IQR is 13.6. So what this becomes is, and let me see here, .9. This is the boundary for outliers, if for being above, towards the right, skewed to the right. So this is our upper boundary. Our lower boundary is Q1 minus 1.5 times the IQR. Now Q1 is 7.9 minus 1.5 times 13.6. Again, that's that IQR we found, Q3 minus Q1. And that comes out to negative 12.5. So what it says is this. if we have our data, here's negative 12.5, and here's 41.9. Data that's between these values are not outliers. But data beyond these values, say out here or out here, these are outliers. So do we have any data values that are less than negative 12.5 and bigger than 41.9 in that Verizon data set? Well, the smallest data value is 0.8, a positive number. So there's not going to be any outliers because the data values were too small. But on this end, we do have 3 data values bigger than 41.9. And those are 43, 55.6, and 77.8. These are outliers. So that's it. Now, what we do is we want to highlight the outliers in our box and whisker plot. And the way we do that is we use a modified box and whisker plot. So the way we do this we're going to make a replacement. Instead of taking the minimum data value, and remember that with the box and whisker plot, it was constructed using our 5-number summary. Our smallest data value, Q1, Q2, Q3, and the maximum data value. Instead, what we're going to do, replace the minimum data value with the minimum non-outlier data value. Whatever the smallest value is, smallest data value, whatever the smallest data value is, that is not an outlier. So in our case, our smallest value was 0.8, but 0.8 wasn't an outlier. The lower boundary for outliers was negative 12.5. So only numbers smaller than negative 12.5 would be outliers. This one's bigger than negative 12.5, so this one won't change. So for our modified box and whisker plot, this is still the far left end. All right. Now the maximum value, a little different. In this case, we're going to replace the maximum data value in the 5-number summary with the max non-outlier data value. Now here we're going to get a change. The maximum data value was 77.8. That's what we had before. But as we saw earlier, any data value bigger than 41.9 is an outlier. So we have to pick a data value that's less than 41.9, but is still the biggest one, but just also at the same time less than 41.9. And it turns out that data value is 38.5. So we're going to lose the maximum of our data and go with the maximum non-outlier. Now we put together our plot. So we start at 0.8. We're going to stop at 38.5. We still have our quartiles. 7.9, 13.9, 21.5. And so that's kind of it. But then I'm going to squeeze these in here. Here's 43. Let me see. Oh, and I forgot an outlier. Back in early, if we back up, there were actually 4 outliers instead of 3. So I apologize for that. 55.6. And here's the one. I think this is the one I skipped. Let's see. Yes, there was 71.3. And then here is 77.8. So this is our modified box and whisker plot. And actually this one kind of is a little more like that. There's a little more skew. So here's the smallest value that is not an outlier. And in this case, there were no values that were beyond the lower limit. So it also happens to be the minimum data value. This is the maximum data value that's not an outlier. And that's because it was just under that boundary of 41.9. We still have our quartiles, 25th, 7.9, 50th, 13.9, 75th, 21.5. But now we modify this. Here are the outlier data values. And that's our modified box and whisker plot. So that's it. If any questions, let me know.